This is section 2.5, part B, on factoring a difference of squares. Before we begin factoring, we're going to look at this product of the binomials x plus 5 and x minus 5 to study what happens. If you have x plus 5 times x minus 5 and you multiply them together, first you would get x times x is x squared, then you would get x times negative 5, so negative 5x. Then you would get 5 times x is 5x, and last 5 times negative 5 is negative 25. So your product would come out to be x squared, let's see, negative 5x and positive 5x add to 0, minus 25. Okay. So what happens is if you have conjugates to the same two terms in a binomial where you have one addition and one subtraction, the middle two terms are always going to add to 0. You're going to get a two-term product. What we're going to look at is going backwards from that. If I have a two-term square that I need to factor, it's always going to factor into the binomial conjugates. So we're going to factor into a plus b times a minus b. Okay. So we've got a few examples here to illustrate that. If I'm trying to factor n squared minus 36, since 36 is a perfect square, I can factor this into n plus 6 and n minus 6, because 6 times 6 gives me 36. Okay. A and b are the value that when you square them give you a squared and b squared. N squared is n squared, and 6 squared is 36. Okay. In part B, I need to do the square root of each of these terms. So my first position to break that 16 down is going to be 4x. One of them is going to have a plus 3, square root of 9 is 3, and one of them is going to have 4x minus 3. I can create my binomial, whether there's a number in front of the variable or not, like this one over here. Okay, but it does need to be a subtraction. I have to have the subtraction, of course, because if I don't have a negative, I won't be able to have one positive and one negative to add to the middle term being 0. Okay. Two more just to factor here. This is a short part of the section. The next one has 49, which is the perfect square, that's 7 squared, and 121, which is 11 squared. So this one's going to factor as 7x plus 11 and 7x minus 11, again, the binomial conjugates. In the last one, 8 and 50 aren't perfect squares, so we're in trouble. We can't use the difference of squares pattern yet, but notice they have a GCF, a factor in common, so we can factor out 2. So we factor out 2, that's going to give you 2 times 4x squared minus 25. Then you've got a difference of squares. So then you can continue to factor as 2 times square root of 4 is 2. So I'll have 2x plus square root of 25 is 5. And I'll have 2x minus 5, my two binomial conjugates. That's the end of part B.